Hello, my name is Zaid Fackenthal, and this is my presentation on the machinability of engineering materials. A quick introduction about myself. I currently live in Stanwood, Washington. I was studying mechanical engineering at George Fox University when I was diagnosed with Ewing sarcoma, or bone cancer. I've currently been successfully fighting cancer for the past 5 months, and have been continuing my studies online through North Dakota University. I currently have a job as a machinist, and some of my hobbies include music, surfing, and swing dancing, as you can see from the collage I made on the right. First off, what is machinability? Well, machinability is the ease or difficulty of which a given material can be machined, or rather, how demanding it is to shape a workpiece of, say, stock aluminum with a selected cutting tool. This could be anything from a lathe to a 5-axis milling machine. There are many influences that can determine whether a material is easy or difficult to cut. But as you can see from the chart on the right, some of the outside conditions not pertaining to the actual material properties include cutting conditions, cutting fluid, and cutting method. To name some actual material properties that affect machinability, there is microstructure, chemical composition, mechanical properties, or alloy additives in a given material. With all these many factors to consider in determining machinability, a classification system called ISO is used to categorize materials by material groups. Each material group is given a first single letter code, such as steel's letter P, and then this is followed by a number of subgroup numbers for this classification. This classification system is a good starting point for determining cutting conditions such as specific cutting pressure, as you can see on the table on my right, where there's the subscript C1 on the K, or for choosing an initial cutting speed. As you can assume, tensile strength and hardness have a large impact on whether a carbide drill bit can successfully cut through a given material. As a reminder, hardness is the resistance of a material to indentation, and tensile strength is the resistance to it breaking under tension. Well, machinists have collected data for each ISO material subgroup and determined an initial cutting speed based on these values. Then, following a recorded trend line of decreasing factor of cutting speed with an increasing amount of hardness, one can determine a cutting speed of any material in a ISO classification based on its new hardness value. As you can see on the right is a table from our book, which can be used with the BHN value to plug into this table and graph. The importance of determining the machinability of engineering materials lies in making job processes more economical and optimized. This can be the goal of decreasing machine runtime, energy consumption, temperature output, or increasing tool life and surface finish. Large engineering companies can look at the material properties they need for a certain application, such as the wingtip of an airplane for aerospace, and weigh that against that material's actual machinability and determine whether the use of this material in this application is viable. So the first question is, what is the definition of machinability? Machinability is the ease or difficulty of which a given material can be machined. For two influences on machinability Some of the ones I've listed in this presentation are cutting conditions, cutting fluid, cutting method, microstructure, chemical composition, mechanical properties, alloy additives, etc. For what is the purpose of the ISO classification system? The ISO is used to categorize materials by material groups, and this is used as a starting point for determining cutting conditions. What is a main influence on determining cutting speed? There is, as I mentioned, tensile strength and hardness are the largest factors in this. And finally, there are many aspects in that a machining company can look at to optimize if they know a material's machinability, but a few of these are to decrease runtime, energy consumption, or increase tool life and surface finish. Here are my citations. Throughout the presentation, whenever images were used, I put a parenthesis with a number to say what source I got those from. I hope you've enjoyed this presentation. Thank you.